7.3 Trigonometric substitution. In finding the area of a circle or an ellipse, an integral of the form, the integral of the square root of a squared minus x squared dx arises where a is greater than 0. If it were the integral of x times the square root of a squared minus x squared dx, the substitution u minus a squared the substitution u equals a squared minus x squared would be effective. But as it stands, the integral of the square root of a squared minus x squared dx is much more difficult. If we change the variable from x to theta by the substitution x equals a sine theta, when the identity 1 minus sine squared theta equals cosine squared theta allows us to get rid of the root sign, because the square root of a squared minus x squared equals the square root of a squared minus a squared sine squared theta, which equals the square root of a squared open 1 minus sine squared theta close equals the square root of a squared cosine squared theta equals the absolute value of cosine theta. Notice the difference between the substitution u equals a squared minus x squared, in which the new variable is a function of the old one, and the substitution x equals a sine theta, the old variable is a function of the new one. In general, we can make the substitution of the form x equals g of t by using the substitution rule in reverse. To make our calculation simpler, we assume that g has an inverse function. That is, g is 1 to 1, and in this case, if we replace u by x and x by t in the substitution rule, equation 5.5.4, we obtain the integral of f of x dx is equal to the integral of f of g of t multiplied by the derivative of g of t dt. This kind of substitution is called inverse substitution. We can make the inverse substitution x equals a sine theta, provided that it defines a 1-to-1 function. This can be accomplished by restricting theta to lie in the interval open bracket minus pi over 2 and pi over 2 close bracket. In the following table, we list trigonometric substitutions that are effective for the given radical expressions because of the specified trigonometric identities. In each case, the restriction on theta is imposed to ensure that the function that defines the substitution is 1-to-1. These are the same intervals used in section 1.5 defining the inverse functions. Expression a squared minus x squared, x equals a sine theta. For the square root of a squared plus x squared, x equals a tangent theta. For the expression the square root of x squared minus a squared, then x equals a secant theta.